morning. We're going to look at some of the characteristics that are involved in science. So studying science and accumulating all of the information that is science. First of all, scientific data must be reproducible. So we are going to collect data basically by making an observation. That data has to be observable. We need to be able to see it or hear it or feel it or test it. And it also has to be reproducible by other science. That's what makes science unique. We can't just do something and then say, oh, that's the answer. It has to be, but we have to be able to get that result over and over again by anybody who tries to do the experiment. We have to take careful measurements, and controlled conditions are required. So when we design experiments, to make sure that we're only testing one factor or variable. And science will not or cannot be accepted until it's verified by other scientists. Not any old crack job can come up and say this is the way something is. But if it can't be verified by other people, by other scientists, by following the experimental procedure, then it's not considered to be scientific. Science must be testable. So when we do science, we carry out the scientific method, which is going to be one of the next lecture videos, right? We make an educated guess or a hypothesis about an observation. We conduct an experiment. When we conduct that experiment, we only test one factor or one variable, and we keep all of the other factors that might play a role in the result the same, so that we know definitively when we get an answer that the cause and effect was related to each other. And when we do science and we make a guess and we carry out an experiment and we find out that our educated guess was wrong, that's good science, right? It doesn't matter if we are right or wrong in what our guess is when we do science. The thing that is important is that we learned something new about whatever it is that we were testing. So even if we get the wrong guess, or if what our original ideas are proven wrong, that's still a successful scientific experiment because we still learned something. And then we can take the experiment a step further in order to come up with a different idea of what might be causing a phenomenon to happen. Scientific laws are going to summarize observations. So these are going to be large amounts of scientific data that is going to be accumulated over time. These are called scientific laws. Sometimes we put these laws into a mathematical formula in order to summarize it in an easy to use way. You'll see this when we talk about gas laws. Scientific theories are tentative and predictive. So good science is replaced by better science. That's the most important term to use. And because you know what, we use the materials and the technology that we have available to us to answer questions, but as that technology and those tools change, we might learn something new along the way. So when science is disproven because we've learned more or we have better tools, that's a good thing, right? Good science is replaced by better science. A scientific theory is an explanation of a scientific event that has been repeatedly tested and verified using accepted protocols of the scientific community, and we use these scientific theories to make predictions about future events. We use scientific models to help explain things in an easier way. So models help explain complicated phenomena, and models can include pictures, they can include objects, anything that can help us visualize complicated types of processes. And science is limited. So understanding science is limited to the technology that we have currently. So I kind of just talked about that. And that technology and innovation and ideas, they change really quickly. So as those things change, new science is developed. So science is always changing. It's never a fixed thing because time allows more data to be collected and to be collected in different ways. So those are some of the characteristics of science.